All right, everybody, so today we're going to pick up where we left off with our final piece of this unit on advanced classes. It's been a long unit. Let me just show you that a summary of this unit can be found in the notes under my website, under Computer Science 40S, under Materials, where you see all the units, and in the unit on advanced classes, there is this thing called the unit review, which is this here, which shows you kind of all the things we've learned so far in this unit. From a review of what classes are, with the properties and methods and how classes can use inheritance or association to communicate amongst classes. We talked about encapsulation between private and public, and then protected, which was a new property that modifier that we discussed. We talked about the use of packages as a way to organize classes in a file system. We talked about the object class and methods like toString and equals and clone. We worked with a few little other things like accessors, mutators, and things like instance of and the static modifier, and something called the enhanced for loop. We did a lot of work on the concept of abstraction, abstract classes leading right from abstract classes to things like interfaces, et cetera, and we kept going. But the thing I want to look at today is another new concept, the concept of generics. So the word generic itself means non-specific. Okay, so if something is generic, it's non-specific. So generic is defined as a characteristic of or relating to a class or group of things that is not specific. In Java, a generic class and a generic method are options that you can create. Okay, they were introduced to enable programmers to specify a set of methods of related types. In other words, you could make one method that worked on multiple data types rather than a specific data type. Same with classes, a class that could deal with a generic data type rather than a specific data type. So for example, it could be nice to write one method that outputted all the elements of a string array. But then the same method could output all the elements of an integer array, or all the elements of a double array. Instead of overloading your method and creating multiple different methods, what if we could make one method? And that would be called a generic method, where we could create an argument or a return type that is a generic data type, and then Java would adapt to this, and the data type would react to this appropriately. To do this, we're going to use angle brackets, and then we're going to put a single letter inside the brackets. Now, the letter itself doesn't matter, but we're going to use a capital T to indicate what the data type will eventually become. Okay, so T could be said that it basically means type, or it traditionally in other programming languages could stand for template or things like that. So this will allow you to later replace that with the actual data type. Now, this can get actually a little more advanced. You can actually have multiple different types of generics. But let's get started with the basic proposition here. Okay, so in our advanced classes test class, okay, and at this point, if we look over our project, we have a lot of classes that we've been building in this unit. All different types and some interfaces and abstract classes and things like that. But what we're going to work on is the one we've been using for the testing, the advanced classes test class. We're going to add a method to the bottom of it. So we've been working inside of its constructor to build all our test code. But now we're going to add another method to the bottom. We've already done this once. We created a check status method when I taught you about instance of. So now we're going to create another method, and this is going to be a special method. This method is going to be generic. So we're going to make it private, static, and we're going to put the angle brackets, and inside the brackets put a single letter. Okay? So again, this indicates that we'll be using a generic data type here. Okay? So it's not like I'd say integer here or double, etc. This is just saying that this data type will deal with generics. It is a void method. It doesn't return anything. And it outputs an item. Okay? Now, here's where it gets interesting. The item that it outputs, we don't know what the data type's going to be. Could be a string, could be a double. So that's where we put the single letter again to indicate a placeholder for the generic data type that will later be specified. Okay? All right. So we're going to say, okay, here's the item. Well, let's start it up this way. We'll make a string of text equal to, okay? And then we'll later output that text onto the screen. But what we're going to do with that text is go to our item, dot, and we don't know what the data type is, but we know that, like we've already seen in the object class, the toString method is built into it. Okay? So we could do that, and it'll output that item as a string. Okay, so if we just keep the method just like that, here's the text, print the text, get the text by turning the item into a string, the item itself won't really matter. Okay, so back up to our testing code. Let's create a string. Start with the data type we expect. We'll just call it item I1 equals a thing. Okay? We will later output I1. So what happens is, this is going to call this method output. It's going to pass it this data type, which happens to be a string. So at the time it calls it, it'll replace this with string when it runs this. But right now, it doesn't know what the data type is. Okay, so let's run this to see if thing gets outputted. The generic data type replaced by a specific data type at the time we call the generic method. Okay, so this generic method is working on I1 to output a string, hopefully, to the screen as we let this thing compile. And there it is. There's the thing on the screen. Okay? All right, let's change it up a little bit. So now let's make an integer, I2. So now we have a different variable, and it's equal to the number 10. Okay? And here's where generic methods get interesting. I now try to output I2. And there it outputs that one. So the same method is working on different data types. Let's try another one, a double, I3. So this is another data type, equals 3.5. A Boolean, I4, equals true. Let's get a little more advanced, a person, I5, equals a new person. So now on I5, we're advancing from simple data types into more complex data types. Okay? So strings, integers, booleans, doubles, those are a little simpler. Now we're moving up to more advanced ones. Let's slip one in before that. Let's actually make person I6. Let's make an object for I5. Okay? Equals a new object. Okay? So the object data type is built in. The person data type. Now we could go through student and teacher and all the rest of them. One of the last ones we made was the Husky data type. Husky will be I7 equals a new Husky. I don't believe we actually have an option to make it as just a non-generic type. So we'll just make the student number 0. We'll make the name just name. We'll make the age 0. And yes, we'll make it a male. So that'll make a very simple looking Husky object. String, integer, double, boolean. And let's just call the output method with all 7 of those. So 2, 3, 4, 5, 6, and 7. And will it output all these different data types? So thing, 10, 3.5, true. There's the object. So the toString method there is just outputting the memory location. There's our person object being outputted. Here's our Husky object being outputted. So all of that is coming together in a neat way. Okay? So the output method is working on a generic item. Let's add a little bit to that output method just for fun. So we'll just say that this is the class. Okay? And we're going to attach to that item dot, and we can get the class. This is a built-in method of the object class, which gets the class, but we're not done yet. I'm going to say dot get the simple name of that class. Okay, run a little bit tight. There we go. So get the class, get the simple name, and then attached to that as a string is, okay? So I'm then going to turn it into a string like that. So let me just show you again. What the method now does is it says, okay, the class is get the simple name by getting the class, as a string is, and then turn it into a string. So I've added a little bit to the output method, and let's run it this time. So class string as a string is thing, class integer as a string is 10, class double as a string is 3.5. So you can see here it's actually pulling the simple name right out of the class. Class boolean, class object, class person, class husky. So you can see here how instance of and now generics can work with any data type at all. So that's pretty cool. Now, the next thing we're going to do is create something called a generic class. So once again, we're going to go into our big package and create a new Java class. Okay, and this, whoops, what did I create there? A new Java class called the box, B-O-X. So this is just a box. Okay, and let's strip down most of the methods and just have basically a constructor. That's all we'll really need at this point, is a constructor for our box class. Just getting rid of some of the comments to keep it simple here. Okay, so our box class, very simple. Okay, and our box is going to hold one property. We can even make it private. Private item. But the question is, what data type will that item be that we can put inside the box? Because when we construct the box, we're going to also put that item in the constructor, and then we'll say this dot item equals item. So we'll assign the parameter to the property. We've seen this before, but the question still remains, what's the data type? So if I said, okay, it's going to be a string, the item is going to be a string, then I use the string as the parameter and it works fine. If I change my mind and I want it to be an integer, then I change the parameter and we're fine. But if I don't know what the item is, I need to represent it with a placeholder like t, which indicates that this is a generic item that will later be replaced with the data type. But when you do it within a class as something like a property, you have to indicate this on the signature line, whoops, of the class to indicate that the generic data type t will be being used throughout this class. That data type t will be used through the class for our box item. Okay? All right, let's add a couple of methods for working with a box. So opening a box. So public open. Open the box will just return the item to us. So here's the item when I open the box because I've encapsulated it. So it's sort of like a get method right here. It's an accessor. We just happen to be calling it open because it's a box. So right here, I put the return type right here. That's what I always do in a method. I return whatever the data type is, and the data type is generic at this point. So I'm returning a generic item to generic data type. And then, yeah, that's probably good enough. In the notes, I include one other method to just sort of peek inside the box. Actually, why don't we do that? So public void look in our box. And all I'll do for that, whoops, is just output it. So sout, what my item is, turned into a string. Okay? Because again, we don't know what the generic item is, so if I turn it into a string, at least then I can output it to the screen. All right, so there's our whole box class. It uses a generic data type. Okay? Now, back to our testing class. Let's box up, for example, item 1. Let's put it into a box. So let's make a box called box 1 equals a new box. And into that we will put item 1. Okay? Now this isn't quite the correct line of code here, because although this is working, it's passing at I1, we will obviously be doing a box 2 and putting item 2 into the second box. And item 2 is an integer. Item 1 is a string, item 2 is an integer. And that looks good. But generally the way that generics work is when you instantiate a generic class, which is what we're doing here, we then give it the data type right here. Okay? So that is done at the beginning of the creation of the object. We define the data type right there, and we usually also define it right here in the constructor. There is, however, an option in Java to not repeat yourself twice. You can actually leave this one out and just put 2 empty sets of those angle brackets there, and that's sometimes just called the diamond right there. Okay, so then when I go to create box 2 with item 2, I specify that box 2 is using integers in box 2, not strings. Okay, so let's continue this. Box 3, 4, 5, 6, 7 will be created for our 7 different items. So similar down here, I'm going to put the 7 items into the boxes. Okay, but here is where I indicate the data types, so that this is a double. This one is a Boolean. This one is a person. This one is a, wait a minute, oh sorry, this one is an object. Jumped the gun a bit there. This one is a person, and this one is a husky. And there you can see that way as well that it makes sure that the data types all match up with what they are supposed to. So I've just boxed up 7 different items, which are 7 different data types, using one class to do this, rather than making integer box and a string box, etc. Okay? And then now that I've boxed everything up, I'm going to look in them. So box1 dot look in, and then I'm going to do that for all 7 of them. I'm going to look in all 7 of these boxes. 2, 3, 4, 5, 6, and 7. Okay? So I'm just going to run that code and make sure it works. And there they are. There's all 7 things unboxed or looked in those boxes. Okay, this is in the slide notes. You can see that in the slide notes, that it talks about the generic data type T. So in the slide notes, I also present comments for all the methods, and then it boxes it, and then it talks about how you do this when you create the object and you use the angle brackets again, and that newer versions of Java allow the second version of the angle brackets to be empty, and that this is called the diamond. Okay? All right. Now, it is possible that we could have had 2 items in our box. Okay? So for example, let's say, and again, a different data type called item 2, which happened to be a different data type than this one, but also we don't know what the data type is. So let's say this one was a different data type. So what I need to do is create a second letter, put a comma, and then, for example, put a U, just alphabetically. So then I could replace this with a U, and now I have a second one. Maybe I'll make that one public. So then I can assign a second item to my box if I wanted to. So then back here, if I wanted to, I could say, okay, oh, so this just broke all those, okay, because now it says it requires 2 data types, not just one. So I'd have to define what the second data type would be, okay? So I'd say string, comma, integer would then work for that one. So hang on, let me get rid of these other boxes for a sec. Just focus on box 1 for a sec. So now I'm saying, okay, for box 1, it'll hold a string, which is this, And then it can also hold an integer. So if I wanted to, I could say, okay, box1 dot item 2 equals an integer, and I happen to have an integer in I2. So that would allow me to put a second data type in there. Now that's definitely a little more complicated. Generally with generics, you're probably going to just need the one generic data type, not two. Okay, but I just wanted to show you that that is also kind of possible. That's not in the slide notes, so I just wanted to put that there. Okay, what is in the slide notes is sometimes you want things to be generic, but you want to kind of limit the generics. So you don't want an unlimited amount of generics possible. Okay? So what I can do with that is restrict it. So let's make our final class for this giant example, another new Java class. We're going to call this class a house. We're going to make a house. Okay, and then go ahead and strip it down. We're going to keep it simple for now. Let's strip it right down. Okay, so here's our house class. All right, so what is our house class going to do? Well, it's going to have a homeowner. A house has a homeowner. So we're going to make a public T homeowner. Okay, so obviously this is going to use a generic data type, T. That's who the homeowner of the house is. But, okay, and then we'll just make a quick constructor. Public house T homeowner. Okay, this dot homeowner, whoops, equals homeowner. Seen that before. So very simple class. Okay, in a lot of ways it looks just like box did at the start. So box an item, house uses an item which we happen to call homeowner, but the generics are working the same. So if I was to test this thing, and I said, okay, I'm going to make a house, house 1. I have to define the data type here. So let's say I'm going to put a person into this house, equals a new house. There's the diamond, and then the constructor. And in here I have to put a person. So I'm going to put person. We have that person. It was something we made way back at the beginning here, person. So I'm just going to put a person into that house. Okay? Pretty simple at that point. So let's add one other little method to our house class. So what happens if we visit the house? So if we knock on the door, actually let's make it that. That'll be a little more fun. So if we knock on the door of the house, okay, what's going to happen is the homeowner will talk to us, okay? But that's a problem because not every class has a talk method, okay? So, oh, how do I do that? Well, I can't really do that here. So to do that, maybe I need to do that at this level. I can say house1 dot homeowner dot talk. And that worked because it knows that the homeowner is a person. So it worked here. Whereas it didn't work here because it doesn't know that homeowner is going to be a person. So I'm going to take that method out. So now it works here. So let's play it. And sure enough, there's the homeowner talking right there. Okay? All right? But what the point of this was is I don't want any generic type. So for example, when I go to make my second house, so house 2, okay? Maybe I don't want it to be a house of strings, right? And I just say that cheese is in this house. And then if I try to make house 2 talk, we have a problem. There is no talk method inside of the string class. But that didn't make sense anyways. I wouldn't want a string to be in the house. So what I'm going to do within this class is right here in the signature of the class, right where I define the generic, I can use a little more code to say that this extends person, which means it will allow you to use any generic data type as long as it's of type person or below in the class sort of structure, the hierarchy. So now, this is an error. I can't create a house with a string inside of it. I can create a house with a husky inside of it, okay? And put a husky inside the house, because a husky is a person. And so house 2 will now work. So now I've used generics, but I've restricted the generics in a certain way. And now both the person and the husky can talk. Okay? So this is in the slide notes. You can see this, that sometimes we want to use a generic to restrict what we're seeing there, and we use the extends or the implements for interfaces keywords inside, and the house example is in the notes as well. Okay, so it can use a generic as long as it's type person or any of the children or the subclasses of the person class. Okay, in the notes you can see I use person, student, teacher, doctor, high school student, computer, etc., 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 to all be used with those generics. In our final example, I want to sort of use these restricted generics inside of our testing class with one other little method. So we had our output method. Let's overload that method. So private static t void output. Okay? But instead of one item, like I do here, I'm going to give it an array of items. So it's going to output an array of items. Okay, so I'm going to loop through the array, and I'm going to use the enhanced for loop. For each item in items, output that item, which will then call upon this method down here to do that. Okay? But here's where this generic method gets interesting. I'm going to allow you to create an array of any data type, but as long as it extends food. And food is an abstract data type, right? It's an abstract class. So I won't actually allow food to be used, but any food object or food child will be allowed within this array. So I've restricted the generics down. So for example, if I made an array of type person, so a person array called people equals, and I'm just going to use the simple way of making arrays. I'm just going to assign it person. I'm going to assign it husky, because a husky is a person. I'm going to assign it student, etc. So here's an array of people, person, husky, student. If I try to output that array, so I'm going to output all the people. It's going to try to take this array over to this method, okay, and run it based on that it allows an array of items, doesn't know the data type, so the data type in this case will be type person. It tries to run it. Okay? So what ended up happening was it called this method instead of this one. Okay? So it had a bit of a problem there in the sense that it just outputted the array as if it was this, and as you can see there, it just said, here's the array. It's a person array, okay? So it didn't really do it properly. What I want is I want this one. So I'm actually going to change this instead of making it an overload. I'm going to do this. And right there you'll see an error. It says, let me zoom in. It says the method is required as a T array, found a person array, and the inferred type does not conform to the upper bounds, which means it's not following the restrictions that it has to be the upper bounds of food. So this actually has to be a food array. Okay? Well, okay, so it's not a food array at this point. So let's rewrite this as a food array. Well, what's an array for? How about the fridge? The fridge equals, so let's put some items in our fridge. Well, let's make the items first. Let's make a donut Krispy Kreme equals a new donut. Okay, let's make a banana called, I don't know what's the name of a banana. Let's just call it Fred equals a new banana. That's weird, but why not? Okay, so there's two food items, Krispy Kreme and Fred. So let's put them in the fridge. So here's Krispy Kreme, and here's Fred. They're inside the fridge. Let's bring that down. So there's our fridge. And now I'm going to output the fridge. Now it does follow the restrictions. That array is of type food. So let's see if it works. And there they are. The two classes have been outputted, donut and banana, inside of that. And if I switch this back to just output instead of output 2, it should also work, okay? Because now when it calls the methods, it uses this method overloading this one down here, okay? So in the way that the methods overload each other. All right, this is also in the slide notes. The exact same methods are there. And that's it. That's the end of this unit finally. Thanks for watching. Hit subscribe if you like it, and have a good day.